Good, good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight to various domains. The topic of today's session is business transformation using platform as a service. Our guest speaker today is Mr. Parvez Mullah, Director and Head Technology and Mobile Group at Fiserv India. Parvez works as a director and heads the Technology and Mobile Group for Fiserv India. He has over 19 years of experience in technology and business management functions. Prior to joining Fiserv, Parvez has worked with multiple organizations, last being Microsoft India, where he headed the Application Modernization and Rationalization Group, and has worked in multiple geographies like Asia Pacific, North America, and Latin American regions. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Parvez.
So thank you, Moini, for the introduction. And so welcome, friends. Welcome to the session today on business transformation using platform as a service. I'm sure every one of you all have seen or heard about platform modernization, business transformation using platform as a service very frequently. What we would like to do or cover in this particular session today is talk about how does, I'll give you a quick overview on cloud, what does platform as a service mean, a little overview about system, software as a service, infrastructure as a service, and then detail about what do we mean by business transformation using platform as a service. So let me start off with the first quick overview about what are the different flavors of cloud that are available in the market today. So if you look at the cloud infrastructure that is provided by multiple organizations, they have, when we say cloud, they actually mean software as a service, which is one of the parameters, infrastructure as a service, platform as a service, and desktop as a service. What we mean by software as a service, I'm going to cover it in the next couple of slides and give you a quick feel about what it means. It's all about applications being available which are as configurable and anyone can actually use the software. Some of the typical models are ASP models that you might have heard in the past. These are standard applications. They are concentrated on providing an organization with the ability to move certain application processing duties to lease third-party managed service. In short, ASPs were not necessarily concerned in the past about providing shared servers or services to multiple tenants, but rather than hosting a dedicated application on behalf of the customer. So over a period of time, most ASPs who did not possess the required amount of application and business knowledge regarding the applications they were running, they were actually hosting it in an ASP-based model. What we have with the software as a service is primarily providing features on hosting the application within the premises on the cloud, and anyone is able to use it over a web-based interface. The common tenets as such on software as a service have been usually build usage, usually multi-tenant environments, highly scalable architecture, accelerated feature delivery, and collaborative and social functionality. What we mean by accelerated and feature delivery is, software as a service applications are often updated or more frequently than traditional software in many cases on a weekly or monthly basis. This is enabled by several factors. The application is hosted centrally, or a new release can be put into place without requiring customer to install new software. The application only has a single configuration, making development and testing faster. So those were some of the tenets, by which now you can actually host the software in an environment and make it available for everyone. The common examples are like Facebook or Salesforce.com that you have seen in the past, which are good social functionality-based tools which are hosted, and you can actually host your applications over it. The second one is infrastructure as a service. So infrastructure as a service is a delivery of technology infrastructure as on an on-demand scalable service. So what we mean out here is you provide infrastructure available to an organization or to an application where anyone can come host their Outlook, various applications over it rather than hosting it in-house. That's basically infrastructure as a service that is commonly known in the field. The main topic that we're going to talk about today is platform as a service. So we'll spend a little time on this. Platform as a service is a model where you have the infrastructure given to the organizations, you have the infrastructure available, the software available, all the features are already there. Now you can go in and configure your application that can be used by anyone worldwide. So these are typical web-based applications or service-based applications that can be hosted on the internet, which are highly scalable for multi-tier environment that can be hosted. So there are a few organizations available like the Amazons, the Salesforce, the Rackspace, Windows Azure, which give you the entire infrastructure, they give you the platform. You can only go now and configure the application and make it available. There are different ways by which platform as a service is made available to the end users. Some of them is through public cloud, through an off-site or a remote-based model where anyone over the world can actually connect to this service and use this platform for hosting applications. There are also some third-party providers like the Amazons, EMC, and so on, who provide private cloud environments as well, including Microsoft, where you can configure the application for a specific organization. Now, what's actually getting much more common in the industry is the appliance model as well. So a lot of organizations are providing banking as an appliance or financial security as an appliance that can be used in a private cloud or a public cloud. And that's when they say they're providing an appliance, they actually mean they're providing the platform as a service, as a model available for the end consumers who can use it. So in short, they don't need to worry about hosting the infrastructure, configuring or making some of these softwares available. They only need to worry about hosting their application and configuring it and making it as easy. I'm sure most of you all have already gone and ventured out the Windows Azure-based platform, which is provided by Microsoft, which allows you to do platform as a service. We'll talk about it in detail as well, which will give you a good feel about how does platform as a service work. In the meanwhile, let me give you a quick overview about where the cloud is going before I set the context and get into further detail on platform as a service. So if you look at cloud as an environment, I'm sure everyone knows that it is getting a lot of popularity. It's one of the hot topics these days with a lot of IT companies in terms of infrastructure planning as well as in terms of revenue and budget planning for their hosting their applications. However, cloud is one of the big waves which is really going to take the IT industry in storm in a fairly different direction or a transformational direction in the next couple of years. If you look at some of the, definitely I didn't want to talk about or predict about the private cloud or public cloud-based environment, but just as a quick snapshot using some data points that are available in some of these industry reports on Forrester and the others, as well as Gartner, is IT cloud services has seen a tremendous amount of investments. If you look at 2009, the IT budget that was planned for cloud-based services was around 17 billion. If you just look at what is planned for the IT services cloud in 2013, I think people are talking about close to 44 million. These are fairly current industry trend numbers which will give you a feel, but I think it is really going over and taking over a new storm. Second is, I would like to give you some more data points on the federal CIO based expectations on what and where the cloud-based business is taking over. Similarly, if you look at the next 5 years, uh, the cloud business is growing almost at a 26% growth rate, with a lot of IT companies especially focusing on the cloud. Now, when we say, all these companies are moving from 17 billion to 44 billion in the next couple of years, what do they actually mean, and which area are they really spending? Is it the infrastructure as a service? Is it application as a service? Or is it more towards software as a service? The current industry and market trends say that most of the budgeting is actually going for platform as a service. The primary reason because IT companies don't want to really set up the infrastructure, set up the applications and servers, in fact want to outsource it. As a result of which, out of the trends of 44 billion, the major amount is actually planned and platform as a service. If you look at the advantages of the cloud-based environment, typically software as a service, infrastructure as a service, and platform as a service, they primarily provide lower cost of ownership, which we've kind of spoken about, reduced infrastructure management responsibility, allow for unexpected resource loads, and faster application rollout. However, software as a service, which is sometimes referred to as on-demand software, is a software delivery model in which software and associated data are centrally hosted on the cloud. Now, software as a service is typically accessed by many users using a thin client via a web browser. But over a period of time, software as a service has become a common delivery model these days. I think that's more important when we talk about the advantages and the others. This model has helped many business applications, right from hosting accounting-based softwares, collaboration, customer relationship, management information, enterprise resource planning, invoicing, human resource. So various set of applications have been hosted on software as a service. The primary cost is relatively low cost of user provisioning. In fact, it is the multi-tenant environment which enables multiple software as a service vendors, to offer applications using the freemium mode. In short, in this model, a free service is made available with limited functionality or scope, and fees are charged for enhanced functionality or larger scope. Some other SaaS applications are completely free to users as well. Like you can talk about Facebook and LinkedIn, and they're available for the end consumers in a free model. However, for premium usage, they do have certain fees. That's what we talk about the freemium model. So there are multiple advantages as such. So it's very quick to host. They do not need to spend about planning infrastructure. And eventually, I think when we get into the business transformation, I'll talk about it in a little more detail. But the key driver for software as a service for growth is primarily its ability to provide a price that is competitive with on-premises software. This is consistent with traditional rationale for outsourcing IT systems, which involves applying economics of scale to application operations. That is, an outside service provider may be able to offer better, cheaper, and more reliable applications. You've seen already some of these vendors on SaaS and IaaS and PaaS, like Salesforce and Microsoft, who really they do understand that there is a revenue cut by not selling some of these licenses, but actually it makes a lot of profit for the end consumers who can directly go and consume it. And we've got some quick real-life examples of how it's actually helped some of the organizations in quickly hosting the application, getting started, setting it up, and without really having to worry about the infrastructure and the platform and applications and so on. A quick slide on talking about how the industry has transformed since the last couple of years. So if you just have a quick snapshot of the environment that was available maybe 15 to 20 years earlier, it was the IBMs and digitals and the mainframe-based environment where you had to actually write a lot of code in a structured hierarchical-based language and then deploy it, have a lot of time in terms of maintenance and manage it out. And at that point of time, most of the solutions were all hosted in-house, so you had to really set up the heavy infrastructure, plan for the cost, and so on. So IT adoption was fairly low. Then it moved on to a client-server-based environment in the last couple of years, where in the late 20s, where you had some of these key service providers setting up infrastructure, environment, and make sure applications were quite easier. Now, since we have moved on to a cloud-based environment, some of the tools that we use are the Googles, the eBays, Amazons, EMCs, Salesforce, Microsoft, and so on, who've actually evolved. Set up an environment, you really don't need to worry about the infrastructure procuring, about purchasing a few additional licenses or worrying about those costs. You can actually go and configure the application. Just make sure your application can be used in a multi-tenant environment, can be leveraged across geographies. You've thought about the data center, the access levels, how it could get replicated from a security, a disaster recovery, or a BCP perspective. But in a nutshell, most of the environments are actually available very easily. So you don't need to worry about hosting applications. You can just go readily and use it. So this has been a great transformation in the industry over a period of time. Let me give you a quick snapshot about the types of applications. So we've spoken about a few, but the key benefit behind all these applications that you see listed out here is the dynamic ability to scale up and down and cost benefits. Typical examples are when you had the Winter Olympics hosted in London, you were actually worried about how do you have or cater to the traffic for X number of users for the ability to view it. And at that point of time, going and setting up the infrastructure for any of the hosting providers would have been a challenge. So they actually, instead of going and setting up the infrastructure, they go and use one of these platform as a service or infrastructure as a service providers, go and configure their app, make sure it is configurable, you can easily go and set up without worrying about the scaling up, traffic, and the infrastructure cost, which would go unutilized after the event is over. Or it is typically in terms of traffic for news webcast or in terms of certain specific events. So at that span of time, you need higher traffic. You need to have higher scaled servers which you can gradually scale up or easily scale up to cater to that needs. That's basically what your platform as a service and infrastructure as a service is going to provide, where you can have the elasticity as a mechanism. You actually don't need to pay for the infrastructure as well in some of these service providers. You can only pay for the worker roles, and we'll actually talk about it. What does that mean in the next couple of slides? The intent, I just want to refocus on the intent. During the entire presentation, we were going to talk about the business transformation. We've given you a quick overview till date on the deck about what does platform as a service, infrastructure as a service, and software as a service provide. Now we'll get into the little more specifics of how does this actually get enabled on for the end customers. Here's a quick example of how Windows Azure as a platform will help the end consumers in leveraging some of the benefits. If you look at any typical application these days that's available, you have a web browser, you have a web layer, a business layer, and a database. There are users spanned across the world who log on to the browser to access some of the data and the content via request and response based technology. We're not going to get into the details of what is the request and what is the response. I presume you understand how do you pass on the request to the server and how do you get a response back. But in a nutshell, this is how it's been working on this while. So what has happened when it starts to overheat in terms of the traffic that is increased, in terms of the volume of users increase for a specific at a specific point of time. So in that case, we start to worry about adding additional web layers, business layers, and the front-end web browsing layers to cater to the traffic. The traditional approach has been adding a few more web servers, adding a few more business layers, setting up the infrastructure in-house to cater to this traffic. Not fairly very reasonable in terms of economics, in terms of setting up the model. So this is what we've been doing. The typical questions asked by IT managers is how much is it going to cost, what happens if the servers are not being used, going to a virtual environment, how much is the capital expenditure involved, and so on. General tendency overall in a nutshell has been scale out. We go and add additional more servers. It's quite applicable for certain applications for banking, especially when you are looking at core banking users. If the number of users increase, you traditionally go and add on the additional budget for your web, your business, and for capacity and for the planning the capacity of your servers. But when it is quite transactional amount of applications, like a news channel that's hosting an event, and you might have 1 million users logging in for that event, and you need to cater to the traffic for that instance. The traditional model that's been working is leveraging something like Azure, which is the Microsoft Windows platform as a service model, which allows you two roles, the web role and the worker role. In which case, you pay per role instance. You really don't pay for the infrastructure. If there is traffic, you would be utilizing the additional expenditure. As soon as the traffic is reduced, you would basically not have to pay for that additional servers. So it's quite elastic in nature, in short, where you can configure the solution to have a mean and a max capacity. You can pay for per role instance, and we'll give you a specific example as well. So that makes it a little more easier for people to understand what do we mean by the web roles and worker roles. But in a nutshell, let me explain a little more in detail. The web roles, in short, for novice, these are Windows 2008 VMs which are hosted on IaaS, and they are IaaS enabled. So anything related to a web-based activity where a user is going to log on to the web browser and request for some request, that's basically the web role. The worker roles are basically the business processing or the activities that actually happen in the business layer. So in a nutshell, the definition would be a worker roles are Windows 2008 VMs with IaaS disabled. This is a common terminology in the industry. But in a nutshell, to just explain to you, worker roles are something which allows you to perform some action, interaction with a database, interaction with a third party. There are also some consumers in the past, in the recent past, who've been a little more sensitive, and they have moved over to environments where you can host applications in Windows Azure, but also configure the application such that pieces of it would be hosted at on-site on the Windows platform as a server. And some of the integral pieces can still remain within the private cloud or within in-premises. Examples of that could be you have a credit card application. Looking at some of the processes, looking at your balances and stuff, that would be a service that's usually placed on the cloud. But any specific transaction that you would like to do related to self-service based functionality, or it would be related to a business processing, or going and paying your balance, which is not really used by multiple users at any given point of time. So that could be hosted still in-house or within a private cloud-based environment. So there are people who are using Windows Azure as a hybrid service as well. So that's an evolvement that's happened. But the advantage out here is, load balancing is part of Windows, the Azure fabric, and automated allocation, automatically allocating the web roles, worker roles, memory, disk space is all dynamic. And that's the beauty behind the Windows Azure-based platform, which is a sheer platform as a service. It gives you a platform, you can go and configure your application and use it without having to worry. Now, wearing an architect's hat, This is where it gets fun and interesting. Now you can have web services in a web role or worker role and be able to open ports in either. You can host Tomcat or any other web server. You can choose to combine a website plus a service in a single role. So the advantage out here is through Windows Azure, you've had certain customers hosting Tomcat as well as the Java-based platforms or PHP-based platforms. So you can actually host anything in the worker role so that it can be made available for multiple, so you don't need to change the hosting as well, because Windows Azure will allow you to run a PHP-based solution or allow you to run a Tomcat-based solution as well. And that's, a fairly dynamic change that's happened, and a lot of public sector companies usually go and explore this functionality of hosting that in Azure. So whenever there's an election-specific application, and this is really from the past where people have used it or are using it. So typically election-based application, they host it on Windows Azure. If it was on Tomcat or on PHP, quickly can scale, use the dynamic functionalities of web role, worker role, and make it applicable. Let me talk about, a little more when we talk about demand burst with Windows Azure. So if you have solutions based on concert tickets or news website, I know a few Al Jazeera channels and Star News and a few of those who have gone in for this model of elasticity and dynamic use, which allow you to basically scale it by demand. So based on the ticket sales, you can actually go and compute the traffic or configure the web roles and worker roles to make it as dynamically available for end customers. So you don't really need to set up a heavy infrastructure and keep it available for end users. However, you can tune it to use the roles as and when required and pay for that. So in short, it actually creates an additional revenue stream as well as reduces your IT expenses dramatically. Now in short, what do you get by PaaS? One is the elastic computing platform, which is I think one of the points that I spoke about. Connect from anywhere with any device. So you really don't need to worry about is there a specific hosted VPN tunnel that I need to make to connect to this environment if it is secure. So it's basically available on the public cloud or the private cloud, so you can connect from anywhere. Low barrier cost for deploying new applications. So there are definitely certain provisions. I wouldn't say it is low barrier cost, but you need to make sure your application can consume or be cloud ready in short, or use the Azure Fabric framework very easily. So you need to make applications that can use it. That is the only provision that you need to make. However, most of the solutions, though they are being hosted in a private cloud or within the premises, they are moving towards cloud provisioning functionality. So you make your solution that is cloud provisioned. So tomorrow you can go and host it on any PaaS provider without really having to go and reconfigure, rewrite, or make it adaptable. I think that's quite a transformational change that's happened in the industry. Most important is pay as you go. You don't need to pay upfront high infrastructure costs for setting it up, configuring it, and so on. It's a one-time configuration that you do to make sure your applications can leverage the platform very easily. It easily reduces your operational cost, directly impacting your profit. It also makes place a marketplace through which you can sell your services. And that's again a transformational point. There were a lot of customers who had solutions available which were catering to a specific business or a specific industry or maybe a specific account as such. Typically in Salesforce, it was hosted, they used to configure it initially and make it available for an end customer. Now we have all these environments hosted on the cloud, so they can actually use your specific database as well, instance of the database as well, dynamically increase the processor roles and scale it. So you don't have multiple environments hosted unless and until it's a compulsion made by the end customer. But quickly, they move to a model and transform the model of being a specific service provider to hosting it on the cloud and catering to multiple traffics and also changing the business model as such. Prior to this, they had instances for hosting and catering to one specific customer. Today they've changed their model and they don't really worry about configuring it for one application. Any changes done for one of the solutions, they can quickly, dynamically replicate it across multiple instances, make it available, and their business model has changed. Rather than serving one customer, they are more worried about or more focused on providing services into their app layer and the business layer and making it available for everyone as a service. And that's the beauty about it. Stop paying, rather than stop paying and stop providing services and reducing the license abuse that used to typically happen. Looking at a totally different dimension of scaling the services and making them available across the world. Since the market is changing and there are various cloud providers available, I think this is more or less what I would feel over here. What to watch for is check your security policies. Make sure when you are building a application, make sure you've identified certain cloud providers who quickly use your solution, integrate it in their PaaS service models very easily. Does the SLA meet the availability requirements? Make sure before you identify a platform as a service provider, make sure whether these SLAs, the service level agreements, are in line with what you are expecting. Just make sure, don't just port an existing application that has been sitting within your security perimeter, but just make sure, you've engineered it to leverage some of the internet security. You have to think about it now. When you say provisioning your application for the cloud, you need to be a little more open in terms of thinking in a slightly larger, broader way of how does it add more value. Similarly, you also need to make sure that your applications are configured in a way where they can use your cloud instance as well as your secure perimeter instance as well. Like how much data because there are some providers who actually charge by the data download and upload as well. So in that instance, you would make sure some of the maximum access data is stored on the cloud in a secured environment, and the less access data that's very internal is stored within your in-house environment in case you're going for a hybrid solution. So those are some of the areas that you need to watch for when you identify a platform as a service. I'm sure there are a lot of loopholes in terms of identifying the platform as a service provider, but you need to be open to these basic providers and what items as well. Now let me give you a quick summary. I think I've explained to you about Windows Azure, how the web roles, worker roles provide elasticity, how do they provide the multi-tenancy based environment, how can you leverage it to not really worry about the infrastructure and the application, but or the software, but really worry about how you can write the application. So in a nutshell, Windows Azure is the OS for the data center. The model is treat the data center as a machine. It handles resource management, provisioning, monitoring. It allows application, it manages application lifecycle as well with the elasticity. You can really give your min load and max load, your virtualized storage, compute and network. It gives you an illusion of boundless resources. So that's basically what Windows Azure does. Once you configure it, it will automatically scale. You don't need to add additional disks or processors or web roles or worker roles. It's fairly easier to configure, and it will automatically, dynamically span across up and down. Provides common building blocks for distributed applications. You can have a reliable queuing, simple structured storage, SQL storage as well. There's also Windows SQL Azure, and we talk about it sometime in the next webinar that we would cover. But there are platforms available to support the various Azure-based environments on database access, SQL storage, through SQL Azure as well. And second is, the application services like access control and connectivity. All of this is inbuilt into Windows Azure. So if you're thinking about a solution which has got high traffic, minimal security constraints, then you can look at it as an alternative for hosting a solution. There are various providers as well that will help you out. and definitely worth exploring. A quick slide about how the keeping the business or reallocating the IT expenditure. We've spoken a lot about the benefits and the economics of moving to the cloud or using platform as a service. A quick one about what IT budgets for data centers or organizations is looking at. Normally 50% really goes into the labor expenses, and this is not really a specific industry or an account, it's quite generic, is what we've learned in the past with some industry standard analysis. And 50% of the expenses really go into the software, hardware, network, and facilities. So when you move into a cloud-based environment, you can actually reallocate your IT expenditure, definitely not on the labor, but at least on the other expenses, of facilitating or moving some of these networks, software, hardware back to the cloud provision platform, where you just need to go and configure the application, not worry about the network, software. It's all managed as a service. And if you have solutions that are lying, which are really not being used so much, then this model is really fairly very attractive. I wouldn't say that you would really cut off the 50% of your other expenses, because that's not feasible, because your PaaS services would be charging you certain costs. But if you look at the dynamics, it would be fairly interesting analysis that you will see. And we'll run you through one of the analysis as well as to how it has actually helped one of the firms without really showing the confidentiality about the provider. But this is how you can actually work by using PaaS, relocate your IT expenditure in terms of cloud computing facilities, and go for the benefits. Now, there are a lot of IT departments that are using cloud environments. Traditionally in the past, the IT services have been performing various activities on the infrastructure layer, application layer, and operation layer. Typical operation layer is authentication, availability, having a lot of services for patch management, backup, network operations center, NOC services, and so on. Now that cost can get drastically cut off by moving to the PaaS, because the PaaS provider would have operations as a service as an inbuilt feature, which you can access over using their self-service desk, their back-end operations, or via the web. Most of the PaaS providers are fairly exhaustive in providing their services, which can be accessed over the internet. You can log in anytime, check it out, view the service provision levels, what are the SLAs, and so on. Similarly, on the application services layer, there are a lot of standard functionality like multi-language, multi-currency, workflows, analytics. Some of the PaaS providers do have that feature and functionality. So you can actually go and leverage it, specifically business activity monitoring services, search functionality for within the website. They're all in-house. You can definitely go and leverage it. And that's what we mean by innovation. A lot of IT organizations and departments are using the cloud for application development to cut and minimize on application service functions, operational functions, and infrastructure functions. Transforming the way we do business, quick is, if this is a quick summary of previously we had standalone servers where you had to manage everything for you. So when you look at infrastructure as a service or platform as a service or software as a service, a quick matrix of telling you what you need to focus on. So in platform as a service, you would be having the database, the operating, virtualization, servers, storage network, everything provisioned for you. All you need to do is, take your application, configure it, and make sure that it's readily going to work. And I think that's the beauty. So the reason is, software as a service and platform as a service, though they are fairly similar, at times you have your custom applications and you don't want someone to use an existing app that's provided by any other provider for various reasons. So you can still host your own applications using the platform as a service. So the hosting is changed and you don't need to worry about the operational services. In a nutshell, moving from standalone servers to providing appliance-based model, and that's what we spoke about. And a lot of IT companies, venturing into banking as an appliance or e-commerce as an appliance. So an appliance is something that you buy from a shop, any retail shop, take it home, plug it, and start using it. Similarly, There are e-commerce applications which are like platform as a service. You go and configure it, start using it, and whenever you want, you can stop using it. That's basically what we mean as an appliance. As a result, most of the organizations are able to provide more value and focus their attention from providing value to providing more value-added services rather than worrying about hosting, maintenance, and other services. A quick view, I know we are uh, uh, running and we have 15 minutes more, but I'll just quickly talk about the next two slides, which talk about the fastest, easiest, and lowest path to innovation and success as to what we mean. So a quick example out here is primarily you have client server applications on the server platform. Ideal time used to be, for hosting the environment, managing the risks, managing the ROI. It used to take a significant amount of time. I'm using a quick example of one of the Salesforce applications that was published on the internet. It took them around 27 months to get a solution functional, a little over 2 years to get a CRM-based solution functional, and maybe at the end of 12 months there was a 50% success whether it would be successful or not. Now, as a result of it, Salesforce as an organization is able to provide CRM as a functionality using PaaS, platform as a service. So once you identify your business needs, almost Salesforce would have the functionality available to cater to your needs. And within roughly a span of 10 months, you're able to really go about in identifying the ROI, and roughly around 7 to 8 weeks is you can get your application running rather than have to wait for 12 months to see your application running. But within 7 months, you can actually go and configure. The only time spent is configuring the application. So your value to the customer as well as realization, your ROI, starts much more earlier in roughly around 10 months rather than waiting for 27 months and realizing what is the benefit. And the success rate is far more higher because you have already a base, you have the infrastructure, you have a base application layer, the application services are there. All you need to do is tweak it slightly and make it work. Quick as an example is Salesforce and a platform which represents the fundamental different model for how IT organization can build and run an enterprise application apps was demonstrated by Salesforce. The model is more aligned with IT success because once we shift the focus of IT responsibility away from the high cost, high risk efforts of infrastructure management to the more strategic efforts of delivering innovation to the business, I think there is in return inherent way of business transformation that you provide to your organization. I think that's what we wanted to cover and convey. A recent independent survey of Salesforce customers validates that the platform as a service is simply a better value proposition for IT, which allows a wide variety of packaged and custom applications and platforms that are allowed for customers to deploy in a fraction of time of traditional platforms to achieve faster results and return on investment and reduce the impact of these apps on scarce IT system administrators, resources, and various other reasons that could be there. So definitely a win-win for all. And let me move on to my last slide, which talks about what is to conclude it, about how does platform as a service actually help. Its shift is towards the hosted and shared infrastructure out here. It can help management provide better infrastructure services and really move away from looking at traditional hosting charges, infrastructure management charges, and explore opportunities towards innovation, doing business in a different way, looking at cost-effective models, and focus on the business and not really worry about the operational infrastructure and application service layers. It's worth exploring an option towards infrastructure. Infrastructure as a service will only give you the infrastructure. Platform as a service will give you the entire model for hosting your application and configuring it. And a lot of ones which use standard Tomcat or Windows Server, .NET as well, configured and installed. You just need to host your application and to start working. And most important, it's a cost-effective model to reduce the spend on infrastructure and environment setup. So that's in a nutshell that I had over here.
Mr. Parvez, I would like to interrupt you.
The services that
Mr. Parvez, are you there? I would like to interrupt you. There's this Outlook
Yes.
reminder window being opened on your PC. Can you please close that?
Sure. Sorry about that. Yeah, so that's in a nutshell that I had to cover, and thanks for attending. And if there are any questions, Mani, we'll be more than happy to answer any of the questions.
Yeah, there are some questions. I've already assigned you the questions. Can you please open your questions window and check them out?
Sure. So let me run through the first question. So I think the first question is, what languages are supported in platform as a service? And I have this question from Lakshman Reddy. So Lakshman, let me restate your question for everyone's benefit and then answer that question. So your question was, what are languages that are supported on platform as a service or software as a service? So the answer for that would be, if you look at certain provisional providers, standard ones like Microsoft or who have Windows Azure as such, they give you the standard Windows .NET framework at 4.0 framework, as well as Windows SQL Azure that is configured. There are a few additional service providers as well which support languages like Tomcat, Java, PHP, and so on. There are a few niche ones as well that support a few additional languages as well. But the common ones are the ones that I've just spoken about. Java, .NET, PHP, and so on are the ones that are available in platform as a service. There's another part also to the question, and let me repeat it, is how much scalability can be achieved? So I think this question is fairly high, but a fairly exhaustive way of asking about what's the scalability. But let me take a shot at it. So when you talk about scalability that can be achieved, it really spans. It depends on how much you can pay, because at the end of the day, you pay per role or you pay per use. It depends about the service provider or the platform service provider that you are going to be accessing. But the standard ones, really scale with a farm or a data center that scales to, more than 2,000 instances of servers, each having further virtualized environments and processors. So I would say, for hosting a solution like London Olympics or the Commonwealth Games that were hosted in India itself, it was on the cloud-based environment. So they were able to cater to a traffic of more than 3 to 4 million users or hits, concurrent hits. So I think that's a good way of talking about scalability as such that is available. I hope that answered that question. Let me move on to the next question. I think the question is from a person called Chandan Kumar. I think it's more towards the readiness piece, saying, how do I go about learning and exploring the cloud-based technology? And since I'm a beginner over here in the cloud, what do I need to learn to understand the cloud-based business and dynamics of computing? So I think it's very simple. I think if you are a beginner, I don't know your technology base, is it Java or .NET? If it is .NET, then I would recommend you quickly to get some learnings on Windows Azure, and I think that will get you started. And check out and explore a few of the solution providers and what services they provide, and that will be a good start. The next one is, the next question is again from Chandan, is how to move ahead and what are the certifications that you will suggest? I think I would normally recommend, there are specific certifications as part of FISA, I would say, but I think there are a lot of providers who have certifications, so you can explore the Microsoft sites or the provider sites and get those details. There's a next question, I think, which from Gaurav Thakkar, which talks about what is the difference between software as a service, IaaS, and PaaS. I did have one of the slides which actually spoke about that. So if you look at infrastructure as a service, that gives you the environment for hosting your solution. They only provide you the servers, the memory, the network, the disk storage, and I/O. If you look at software as a service, it would be a configured environment like Facebook or LinkedIn or Salesforce, which the application is not really Salesforce, but Facebook and LinkedIn, where the application environment is already configured. You can log in at any point of time and access your solution. You have very less flexibility. Maybe the base application layer is provided. You can just go and consume that software and it would work for you. What PaaS does is it gives you, you can host your own applications over there. It gives you the infrastructure, it gives you the environment, it gives you certain softwares as well that would be required for hosting a solution like SQL Server, Windows SQL Server, or your .NET layers and so on. But you can go and host your own application on it. That would be the core difference. And there's another question from Nidhi Sethia, and the question is, how's the security implications are when we deal with a cloud-based environment? So again, the question is related to security in the cloud, and this is a fairly exhaustive topic on how do you manage security-based applications. I would say, I think there have been various stances by various organizations on the security on cloud. But over a period of time, the security on the cloud has really enhanced. There are a lot of mature functionalities in terms of isolating by authorization services, authentication services, and so on. So there are implications. I wouldn't say there aren't any, but it all depends on how would you actually code for it in your PaaS-based environment, how you use it. You need to really put additional layers of security for accessing the data. Also not really worry about accessing the data, but also seeing what data you want to put in a private cloud, hybrid cloud, or within a custom-based environment within your own semi-secure semi-perimeter. So it all depends on those configurations and the way you've hosted your application. But yes, there are security implications. There are a lot of frameworks available as well that help you configure as well as manage some of the base layer securities, but rest of it, you have to configure it and make sure that is provided and available. But there are security implications that you need to work on. I don't think in the time limit that we have, we can cover it in detail, but it's a independent topic of its own to talk about security in a cloud-based environment. But in a nutshell, yes, there are a lot of parameters that you need to think of. There's the next question from Venkataraman, and the question is basically, how transparent is the charging off process when it is based on web role or worker role? Because my users could be sharing the web roles with users from another customers. Definitely, I think that's a very interesting question. There are certain models. I think what you've been talking about is when this model was really evolved a couple of years back, there were various discrepancies on the charge off between the worker roles cost charge pay per use as well as the web role pay per use. I think it's been evolved. There are various mechanisms and contractual things that you need to work out with your service provider. But yes, this has really evolved. There has been certain gray areas maybe a few months earlier, but they have been resolved, and there is better transparency now by providing metrics and monitors by which you can go and assess it at any point of time. Also, your stabilization phase where you can actually go and explore what would be the cost by actually using it in that simulated environment and understanding with certain traffic loads. And you can model it of how the traffic increases on the web role and worker role. What is the cost you're going to incur? That transparency wasn't there earlier, but I would refrain myself from providing any cost to you on what they are because they're dependent on the provider. But yes, there has been drastic improvement in terms of transparency and costing by providing models and simulations on what would be the costing and charging. The second question is from a person called Prasad Bhagwat, and the question is, does PaaS is secure as we are outsourcing data to cloud provider? I think the answer to that is the security piece is not really something which PaaS as such would provide. It depends on how you configure your application or write your application. PaaS is only an environment by which you can host your application with certain services given by the infrastructure. Definitely, and I mentioned it in one of my slides, when you work out the SLAs, you identify the provider, you need to look at those security-based principles and models. However, um, how you actually write your solution and your code for leveraging the features, I think is more critical than worrying about the PaaS provider, because the PaaS provider caters to not only you but caters to multiple other applications and vendors. So he needs to be quite exhaustive enough in supporting and catering to certain traffic. I think in the interest of time, I think we've gone through all the set of questions now. And over to you, Mohini, because it's over the hour, and I think let me know what do you want to say.
Well, thank you so much for the insightful presentation, Mr. Parvez. I'm really thankful to you for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of this session would be available on techgeek.com on the webinar page by evening. Thank you all. Have a great day.